circumference is 2 pi r. So the radius r, that is the section, a line that goes from the center of the circle to the circumference. That's a radius. A diameter is if you go all the way across from one point on the circumference to another and you pass through the center, that's a circumference. So what's the relationship between the diameter and the radius? The diameter is twice the radius. So we'll do some converting back and forth between the two. But for now, just know circumference is 2 pi r, right? So if I said that r is 12, for example, let's say r is 12, then the circumference would be 2 pi times 12. Let's say that's inches, okay? So it'd be 2 pi times 12 inches. And in other words, that would be 24 pi inches, right? So obviously in circumference, we're just talking about a length here. So then your inches, the unit is going to be just inches to the first power. And then when we talk about area, the area of a circle, okay, so that's your first equation. Circumference equals 2 pi r. Area is pi r squared. So let's say that the radius is 12. Then the area would be pi times 12 squared. And that would be 12 inches squared. So when we're done with it, right, when we compute that, it would be area equals 144 pi inches squared. That would be if the radius was 12. So 144 pi inches squared. Is that okay? This is math that you've done before. Like this has actually been taught to you since pretty much middle school, right? More or less. So that's where we're at. We know some stuff about circles, right? This is really a review. You know this from, like I said, middle school pretty much. So area of a circle, pi r squared. But really what we're getting at here in geometry, we don't want to know just the area of the circle. We want to know how to calculate the area of a sector. And so here's what we need to define. If I have a circle, my goodness, if I have a circle, and I've got an arc here, theta. I've got an angle here, theta. That's going to, when it's the word is subtends. So if it subtends this arc, what I'm saying is that this theta, this angle, is intersecting with the circumference at two different points, here and here, right? That's what I mean when I say subtend. So we inscribe an arc by creating an angle in the center of the circle. So this central angle subtends the circumference and intersects twice and creates an arc. So we want to know how long that arc is. And we also want to be able to calculate the area of the sector. So this little piece right here, the area of it, that's called a sector. All right. So let's work on figuring out arc length and sector area. Okay. So let me give you an example. So the example would be like a piece of pizza. You have 8 equal slices. They're perfectly equal. So that means that you have a proportion 1 to 8, right? So you have one part of the pizza and 8 total parts, right? If you add them all up, you have 8. That's the total. So if you were trying to find out what the area of the sector is here, you would need to know the total area of the pizza. So the total area of the pizza, let's say it's a 12-inch diameter across the pizza. That means that the radius is what? If the diameter of the pizza is 12 inches, what's the radius? 6. Okay. So then the area, the total area of the pizza would be pi 6 squared, 6 inches squared. That's the total. That's the total area. The part of the area that I want to know, this part, right? This one piece of pizza over here, I want to know this area. Well, that is the thing I don't know. That's X. That's the sector's area. So now what I'm going to do is I'm going to multiply both sides by 36 pi. So it's going to be 1/8 times 36 pi. That's going to be equal to the sector's area. I'm just multiplying both sides by pi times 6 squared, which is 36, right? So I'm multiplying 36 pi by both sides. That's canceling out, and I get 1/8 of 36 pi equals the sector's area. So 1/8 of 36 is not an even number. It comes out to like 4.5. 4.5 pi equals sector's area. So you can leave it like this. Okay, this would actually be 4.5 pi inches squared, because remember, we squared inches over here, right? So you can leave it like this, 4.5 pi inches squared, or you can put it in your calculator and you'll get a larger number. It'd be 4.5 times 3.14, blah, 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 blah. So what do you get when you put that in your calculator? Put it in your calculator. See if you can find pi on your calculator. That's the challenge. Second in that, yeah, the caret button. Multiply that by 4.5. What do you get? 14.14. Yeah, so 14.1. Okay, 14.1 inches squared. That's the area of the sector. What do you think? So we're just setting up a proportion. So let's do one where we have the proportion is actually of degrees. Let's do one like that. So here's a diagram right here. Focus in on this. So I've got 53 degrees in this arc that subtends the circumference here, right? So I'm looking to find the area of the sector. So here's what I would do. I would put 53 degrees over the total number of degrees. How many degrees in a circle? 360. Okay. And I'd set that equal to, I need a like proportion on the right-hand side. So this is part to a total. So I need part to a total. And I'm looking for the area. So the sector's area would be the part. The total would be the total area. What's the area of that circle? Pi I squared. What's I? What's the radius? 4. So 4 squared. Okay? So I'm going to multiply both sides by 16 pi. So it's going to be 53 divided by 360. Those degree measurements, they'll cancel. So that'll be a dimensionless number. I'm going to multiply that by 16 pi. That will be the sector's area. The area of the sector. Okay? So 53 divided by 360, what's that in your calculator? Good question. Try it. See what happens. Okay, it's a small number, right? Multiply it by 16 pi. $7.4? Is that what you got? What'd you get?
0.46.
That's just this part, or did you multiply by 16 pi? So 7.4, this is going to be feet squared. That's the area of the sector. All right. So now I've just got one more example to show you. I'm going to find arc length, and I'll do it with the first problem on your problem set. Okay. So just take notes on the sheet you've got. I'll hand out your problem set in a second, but see if you can follow along with this. So here, I've got this arc here, but I'm looking to find this time the arc length, not the area of this sector. So here's what I do. I set it up very, very much the same. 165 degrees over 360. That's my part to the total. But this time, instead of area, I'm going to use the circumference, the total circumference. What's the circumference of a circle? 2 pi I, right? 2 pi I. So what's I? It's 9 here, right? So 2 pi times 9. So in other words, 18 pi. And what I'm looking for at the top, this is the length of the arc. This is the length of the arc. So I'm going to have 165 divided by 360 times 18 pi, that will get me the arc length, okay? And this is just going to be in yards, okay? So the unit of measure is yard, so it's going to be in yards. We didn't square anything. It's just 2 pi yard, right? I'm trying to teach you how to speak like somebody from New Hampshire. It'll benefit you in the future, I'm sure of it. So what does this come out to in your calculator? 165 divided by 360 times 18 pi. What do you get? Yeah, okay, perfect. So 25.9. There we go. 25.9 yards. Okay, that's a length. Does it make sense? Yep. Beautiful.